first of all, it seems that I picked the wrong time slot for the presentation. It should be 20 minutes, not 40, so we'll finish early. But I guess that only gives us a better starting position for the food, so it should be fine. Okay, so let's get started with a story. So when I was a student at the university, I lived with other developers. So every evening turned into a small meetup where we talk about our programming language, which was Java, and nicer programming languages, which was pretty much everything else at that time. And we kind of looked at them with envy. We have .NET with Linku, and Silverlight, which doesn't exist anymore, but it did. And it kind of looked that Java was designed by someone who had beauty described to them, but never seen it. So we looked at the code that we have written every day and discussed it, the design patterns, the libraries, and then I wonder how would it look like, what would it look like if we had AI at that time. So it seems that it will go somehow like this. So I wrote some prompt, it generated the code, and I think it works. Well, yeah, I think it works. Of course, at that time we had like 6 months experience combined, so I think it works was explaining pretty much everything we've been doing. But still, I think this stays about the AI, especially since people agree with that. So the Perry and the team from Stanford in 2023, they find out that using AI for coding makes the code less secure, but we think it is not secure. And after the talk in this room yesterday about attacking the AI coding assistants, I think it is even worse right now. So also the state of AI engineering by LangChain, 38% teams run online evals, 53 offline. And so half of the people who use AI have no clue if it works. Well, at least half, because I think that those who use some generic eval libraries don't measure anything that matters. So what we are going to do right now, I will show you 3 ideas that kind of work, then I will tell you why they might not work, and something that maybe will fix them. But it's going to be tricky. So in distributed systems and in machine learning, we've been using something like shadow testing. So you have a shadow deployment or A/B testing, whatever. So you run multiple versions of compatible model or prompt with the same data, and you compare the results. And it works well with deterministic machine learning. You have the same input, the same output, so you get some meaningful difference. With AI, you have same input, same model, maybe the same output. That kind of depends on the sampling parameters. So instead of comparing the results, you should be comparing the distributions of the values. So what do we care about regarding the distributions? So maybe things like latency, the waiting time for the full answer, or the time for the first token, or maybe cost of the response, because AI agents can get very verbose, and that's not always the best idea. The refusal rate, if you add more safeguards, you get more rejections of valid requests, and of course eval scores per category. Well, so what did the user want to achieve, and if they got it. And why per category? Because in aggregates you can hide a lot of regressions. So if you have 5 categories that improved by 2-3% and one that got worse by 10, probably care about the one that got worse, but you might not see it if you just look at the aggregate value. But of course, in machine learning, traps everywhere. So of course, we will have some also here. So first one is the bias traffic. And those, of course, are things that I have done stupidly. So if you sample the traffic from the top 3 customers, probably the 4th one will hit a category you never tested. If you sample some time frame, like 1 hour during the day, for example, the one where you are in front of the computer, you will miss the bad job that runs at 3 a.m. and probably many other things. So instead of comparing the divs, we'll compare the distributions and measure the metrics per category, and also watch for the bias in data sampling. But who decides if the distribution is better? That's the question we will not answer yet, but maybe do it later. The next thing that we can kind of copy is our circuit breakers. So the classic circuit breaker is something that watches out for error rate, and if it exceeds a threshold, we trip the breaker, fall back to the default value, and wait for it to recover. Waiting for it to recover, in case of AI, it's really tricky, but we have a few assumptions. Yeah? First of all, the failure looks like a failure. So it's an exception, timeout, 500-something status. And if AI, well, they do succeed at the protocol level. Yeah? You get the string or whatever, have a valid response code, correct structure, totally wrong content. So how do you do it if the system that you are looking at has a failure mode that looks like a success? So maybe we should be looking at different things, like some hard limits, like the maximum number of steps, maximum tokens, the time budget. Of course, loop detection is always nice. Yeah? If you have an agent that is calling the same tool with the same arguments twice in a row, it probably doesn't make any sense. And for some very expensive actions, I would suggest have the human. But of course, the human will be another problem for later. So what can we track? So if you cannot look at the exceptions, you need some proxy. So for example, logprop, if you have it, retrieval score, maybe schema validation, if that's what you are doing. But who decides what counts as a confident answer? Yeah? Who sets the threshold for the circuit breaker? And we have eval harness, yeah, because AI doesn't fail loudly. And I remember applications failing loudly. For example, the first public demo that I ever had that failed was at a stage like this, 30 to 60 people. We were showing an Android app, and suddenly half of the stream was showing null pointer exception, because it seems there is a difference between no list and an empty list. So I, of course, had worse null pointers since then, but I still remember this one. And it will not happen with agents, yeah, because they don't fail like this. They just quietly become useless. So what do we have to do? We have to look at our data, for example, the assumptions that we have. Because if we get this wrong, there's no way to fix it later. I remembered one project when we almost got it wrong. It was not even AI related, not even machine learning. It was more like data for marketing. And we had some high-value locations that had to be tracked and advertised. And we had an assumption that they are all by the sea. And that's I plot them on the map, and it turned out they are everywhere, like in the middle of cities, in the middle of the land, mountains, by the sea, of course. So I went to the product team, and we removed 40% of the candidates for this project. So it was basically saved by looking at the data for 5 minutes, but it was nobody's job at this time, and the assumption was old, made sense at some time. So we just continue doing it, and nobody checked. So maybe there is some assumption that nobody bothered to verify, and is going to kill your agent, or any AI system, machine learning system, whatever. Okay, I will do something that you will not like. Let's wait, look at your data until looking at it is as painful as sitting on the stairs. And of course, we will not wait 30 seconds, because every second on this over there is like 50 there. So how do we look at the data? We categorize it by some categories, yeah, by intent, so what the user is trying to do, and if they succeed. But the domains, so there might be some product or customer segments that you are caring about, by the length of the request or whatever you are processing inside, because the short ones usually break in a different way than the longer ones. And by the language, because everything that works in English breaks in everything else. And the point is not the categories. You will find better categories later by doing it one or 50 times more. But the point is that you can spend one afternoon with Excel and just stop pretending that every request is the same, because most likely it is not. And the same we do with our failures, yeah? Because we have at least 6 things that might happen. I bet you will discover more. So we might have some hallucinated facts, some schema violations, wrong refusal, wrong tool calls, infinite loops, off topics. And basically the idea is that if you cannot name it, you cannot fix it, and you cannot talk with people, for example, with your colleagues in the afternoon when you are discussing your job. So, and then we build our eval harness that will have at least 3 layers. So the first one is our input and output set per category, of course. And as I said before, we are not watching for the values, we are watching for the distributions. Yeah? So we will look for new categories there or the shift between categories, because this tells us that the production data changes and maybe something that worked in the past will not work anymore. Yeah? Then we have the LLM as a judge, of course, with some checklist for scoring the results, and a small set that was created by people to grade this LLM. But who actually grades it, and do they use AI to do it? Because I think they do. So every pattern here has a human at the bottom. Yeah? So someone has to decide what the distribution looks like and which one is better, what counts as a confidence threshold, and someone grades the test set. And I will have to tell you something about that human. That human could one day remember 200 lines of code just to gossip about them with colleagues, but the same human cannot babysit an automated system, and not because that one is broken, but all of them are. At least that's the excuse I'm telling to myself. And I have some research to back that claim. Parasuraman, 1993, they had operators monitor an automated system that worked fine most of the time, but sometimes didn't. And after 20 minutes of working with something that mostly works, people stopped catching the errors when it stopped working. Of course, I have to tell you something about this one. It's a little bit exaggerated because there were 2 parts of this research. This 20 minutes is when they don't do only one task, multitasking or are distracted by something. If people focused and did only one task, there was basically no effect. They were not affected by this problem, and they could work with the not perfect system for a long time. But in 1993, they didn't have apps on the mobile phone, Slack, emails coming every 5 minutes. So I think we are in this case when we are kind of multitasking and are distracted. So 20 minutes seems about right. And of course, we had to fix it somehow. So I looked at the ideas how to fix it. And there's research on this. So we had 2 training conditions. Yeah? You can tell people that the system can fail. For example, you get presentation from the security team. Don't click the email, links in the emails. Or you can make them experience the system failing. So send them an email and show them the page where you got rigged. And only the second condition reduces errors. So the lecture doesn't really work, but the file drill does. So what I'm suggesting to do. Some years ago, the buzzword that people talk about here was chaos engineering, and I think we can do the same for humans. So to our review queue that we use for the training set or test set for agents, we can add some known bad output examples, and we check if the reviewers catch them. If they do, then we know that the quality of the review is at least decent. If they don't, then, well, it's not. So we have some metrics telling us how good the reviewers are. So what do we do tomorrow, or today, or next year, whatever? Yeah, so we categorize our inputs, the failures, we pick the biggest bucket, then we turn it into our test set, and of course we version it like production code, so we have it in the repository with some comments, history of changes and so on. And we inject a few problematic examples that people should be catching. And yeah, I'm not saying this because I want those reviewers to get fired, of course. We should treat it like the security training, so you don't usually, I hope, fire people who click the link in the email during some security training, but yeah, you can just track it without naming who was the words reviewer. Yeah? And yeah, I don't have comments on that yet. Maybe that's the topic for the next year. We'll see. So what I want you to do is to look at the data, because the joy of programming, the thing that make you talk with your friends and colleagues in the afternoon about your job was always looking at the weird stuff, things that don't work. But now we find it in our data, not in our code. So yeah, that's pretty much it. And the text version of this talk is at this address. You don't have to take pictures. It also has, I think, one more story that I forgot to say. Okay, any questions? Actually, I should take a picture of you to prove that someone cares about MLOps still.
Thank you. Questions for Bartosz?
You can also send them to me later.
Yeah, offline, yeah. All right.
There are links everywhere on this website.
Okay, so yeah, so let's thank our speaker for his presentation. Thank you very much.